that's a little thing I am working on composing. All right, so let's see what we got here. So I'm going to continue talking about derivatives of inverses. Just look at a few more examples on this part of the video, similar to what we did in part 2. So here we go. All right, so what we have in this particular problem is it looks like we have a function f of x equals 2 minus x squared, and it's defined on x greater than or 0 because this is not a one-to-one function. I mean, this is a quadratic. I'm going to show you what I mean by that and why I've defined it for x greater than 0. So if I graph 2 minus x squared, that's a parabola opening downward. Okay, and see, this is not a one-to-one function. It fails the horizontal line test, but if we just let x be greater than 0, then we have this right part of the parabola, which is a one-to-one function, so that's why I'm doing that. Okay, so we're going to look at finding, in this problem, we're going to find the derivative of the inverse evaluated at -7. Okay, so there's really two ways we can do that. One way is we can just start off by finding the inverse. Okay, we can do this. So let's go ahead and find our inverse. So we have y equals 2 minus x squared. Again, we need to switch the variables. So we would have x equals 2 minus y squared. And then I'm going to rearrange. I'm going to move the y squared to the left. I'm going to move the x to that side. Then I'm going to do square root of both sides. So I would get y equals, technically, plus or minus square root of 2 minus x. Now, the thing on this is, since this is only defined for x greater than or equal to 0, we're going to want this to be positive for that reason. So our inverse is going to be this then. Okay, so we're just going to write f inverse of x equals 2 minus x to the 1/2 power. Okay, so we can do the inverse on this function pretty easily. A lot of times on these problems, it's impossible to do the inverse algebraically. So I'm going to go ahead and do the derivative. Okay, I'm going to do that. Okay, this is chain rule, so I've got 1/2 2 minus x to the -1/2, and then this is chain rule, so I have to multiply by the derivative of what's inside. The derivative of 2 minus x is -1. So I end up getting -1/2. Write this like this. So I've got -1/2 times, and then I'll just bring this down to the bottom. That's 1 over 2 minus x to the 1/2. So the best way to write the inverse would be -1 over 2 times the square root of 2 minus x. Okay, so that is my inverse. Now what I need to do is I just need to do this. I just need to evaluate this. So I need to do f inverse, the derivative, evaluated at -7. So I'll put my prime like that. And then what I'll have, just plug it in. So I get -1 over 2 times 2 minus -7. Okay, so that'll be -1 over 2 times the square root of 9. So that is -1 over 2 times 3. So that's -1/6 is what that is. So this is one way to do the problem. So it's -1 over 2 times 3, -1/6. Okay, so that would be the answer of the problem right there, if you wanted to do it that way. There is an easier way to do this, and I'll show that in this other technique. This other technique is you're kind of forced to do it this way. So again, just kind of talking through what I did, I found the inverse by interchanging the variables and solving for y. Since x was greater than or equal to 0, I needed to use the plus because y also needs to be greater than or equal to 0 on this, so I do that. And then I did the derivative using a chain rule, got -1 over 2 root 2 minus x, and then I evaluated that derivative at -7 like the problem asked, so I got -1/6. Okay, so here's another way you can do this. First of all, what we need to do is we need to find what x value provides -7 on f of x. So what we're going to do is we're going to set f of x equal to -7 and then solve for x. So I'm going to do that. I have 2 minus x squared equals -7. And I'm going to rearrange this. I'm going to bring the 7 to the left, so it's plus 7. I'll bring the x squared to the other side, so it's positive x squared. Okay, so I end up getting this. I do the square root of both sides. Technically, I get x equals plus or minus 3. Now, remember, x has to be greater than 0, so we're going to wipe out the negative one, and we're just going to have x equals 3. So what we get is we have a point. X is 3, y is -7, okay, on the function. All right, so that's the first thing we need to do. It's important that you figure out that 3, okay? Now what we can do is we can do the derivative of f of x, which is real simple. That's just -2x. And then what we can do is we can evaluate that not at -7, but on 3, because we're working with an inverse. So you have -2 times 3, which is -6, and then we can conclude then that the derivative of the inverse is going to be equal to the reciprocal of that, so it's -1/6. Okay, so that's an alternative way of doing that problem. Okay, a lot of times the second method is the way to do it. So again, what I did, instead of calculating the inverse, I just set the function equal to -7, so I can get the point on the inverse. So basically, -7, 3 is on the graph of f inverse. That means that 3, -7 is on the graph of just f of x. Okay, so I do the derivative of f of x, which is real easy to do. That's -2x. I evaluated at 3 now to get -6, and then when I get the derivative of the inverse, I just do the reciprocal like that. So you're going to end up getting the same answer. I think the shortcut's a little bit easier, and that's the way you're going to do that most often. Okay, so that would be the idea of how that goes then. Okay, so like magic, these graphs pop up. I just want to review kind of what you can do on your calculator on this. I'm not going to take a lot of time to do this, but I graph the function 2 minus x squared with x greater than or equal to 0. So you can enter it like that, so it only provides, half of that quadratic function. The inverse was positive square root of 2 minus x. So you can kind of see how these graphs have that symmetry about y equals x. But the idea is, if we do the derivative of the function, this is basically finding f prime of 3. When we do that, we got this slope of -6. Okay, that's what the graphing calculator is saying on that. Then if we do the derivative of the inverse and evaluate that not at 3 but at -7, we end up getting -1/6. And that's what this is showing, is that's what that decimal is. That's the same thing as -1/6. So it's kind of good to go through and look at these graphs when you do some of these problems if you need to. I think it gives a really, really nice connection to learning this material, personally. Okay, so now I'm going to go to another example. Okay, just a little bit different example, kind of doing the same idea here. So this time what we have is we're given this function. So f of x is x plus radical x, and we're going to find the derivative of the inverse at 2. Okay, so here's kind of what you get into in a problem like this. So if you want to try to do the inverse, let's see if we can even do that. Okay, so let's just do this. Let's interchange the variables. So we would have x equals y plus square root of y. Now solving for y on this would really be difficult. I mean, you'd have to square both sides. It's really going to be difficult. So, it's just too difficult. So this is what happens a lot of times on these problems. If finding the inverse is too difficult, then don't bother doing it that way. So the shortcut, what we're going to do, and this is what we're going to focus on most of the time, is first of all, we got to do two things. Okay, we have basically on F inverse, we have a point 2 comma something. Okay, we don't know what that is. We don't even know what the inverse is, and we're not going to find the inverse. So what we're going to do is we're going to set the function f of x equal to that 2, kind of working backwards to find what that number is then. So we've got x plus the square root of x is equal to 2. So we need to see if we can solve this equation then. Okay, so this is a radical equation, kind of like you do in college algebra. What I'm going to do is I'm going to isolate the square root of x. So I'm going to move the x to the other side like that. And then I'm going to square both sides. The reason I'm squaring both sides is basically because I'm trying to get rid of that radical. Okay, so if I square the square root of x, that gives x. If I FOIL this, and you can do this in your head using the shortcut, or if you want to write out the steps, that would be 4 minus 2x minus 2x plus x squared. So that would give x squared minus 4x plus 4. You can also do that in your head if you want to. So we have a quadratic equation. And what I need to do is I need to move this x to the other side and get this set equal to 0. So I get x squared minus 4x minus x plus 4. So I'm moving the x, its sign changes. So I get the factorable quadratic equation, x squared minus 5x plus 4 equals 0. So now I can factor this. So I've got x and x, I've got 4 and 1, and a minus and minus. So I end up getting on this x equals 4, and I get x equals 1. Well, one of those answers doesn't work. And what happens on this is you have to kind of go through and check your answer in the original. So if I look at 1, the original equation that I was doing was this right here. So let's plug in the 1 and see if that works okay. Just plug 1 in. You would have square root of 1, whoops, that's not right. Square root of 1, nope, like this. Plug in the 1, so you'd have 1 plus the square root of 1 equals 2. Okay, so that works. So that's an answer. Okay, but notice what happens on the 4. If you plug the 4 in, you would get 4 plus the square root of 4 equals 2. Well, that's not true. We call this an extraneous solution. Okay, you learn about this usually in college algebra pre-calc classes. So that one you got to throw out. That's no good. So anyway, what we get is now we know that what we really have is on the graph of the inverse, we have this 0.21. Okay, so we have that. And that's real important in figuring out this problem then. Okay. All right, so that's the first thing you got to do. Now, the second thing you got to do is we need to do the derivative of f of x. So I'm going to write this as x plus x to the 1/2 power. Then we're going to go ahead and do the derivative of this. So the derivative of x is 1. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. Then we have plus 1 over 2 x to the 1/2. So we get as our derivative, we get 1 plus 2 over, or 1 over 2 root x like that. Okay, so now what we need to do is we need to evaluate the derivative, not at 2, but at 1. Okay, that's kind of the key thing. All right, so it's going to go like this. We're going to evaluate this derivative at 1. Okay, so what we have is 1 plus, see those 2's cross out there. So you have 1 over square root of 1. So that's 1 plus 1 over 1, so that's equal to 2. All right? And then we can conclude this. We can conclude that the derivative of the inverse at 2 is equal to not 2, but the reciprocal of that. Okay, like that. So that's kind of what you have to do. So the shortcut on this, what you have to do is if you're finding this, you have to find the y value on the inverse when x is 2. How I do that indirectly is set the function equal to 2, solve for x, and we got x equals 1. That was the key. So that means you have the point 2, 1. That means on f you have the point 1, 2. So what you can do then is you can do the derivative of f of x, which we did, evaluate that at 1, and then do the reciprocal of that to get the derivative of the inverse at x equals 2. Okay, so that's how that works out. All right, so pause and look over that a little bit if you need to. Otherwise, we'll move, and I'm going to have you do these two problems right here just with the shortcut only, and we'll see how that goes. Okay, so here is what you should have got, and this will end part 3 of the video. So the first one, you should have got, the answer was 1/3, and then the second one, the answer was 1. I also provided graphs, which are recommended if you're not confident in your answer, you can always check what you're doing on these. So again, let me just sort of talk through this if you didn't get this. So we're interested in f inverse of 1, and that means that we have a 0.1 comma something. We need to figure out what that value is, because when we flip that, that will be on the graph of the function. So I set x minus 2 over x equal to 1. I multiplied by x to get rid of the fraction. So I ended up with x squared minus 2 equals x. This is a quadratic equation. Get one side equal to 0 and factor. So when you factor, you have x minus 1, x plus 1. You end up getting solutions x equals 2 and x is negative 1. However, in this problem, x has to be less than 0. So that means you got to use the negative 1. Okay, then it's a matter of doing the derivative. So you do x minus 2x to the negative 1. The derivative of this function is 1 plus 2x to the negative 2, or 1 plus 2 over x squared. Now plug in, see what you have is you have the point 1, negative 1 is on the inverse. So that means negative 1, 1 is on the function f of x. So when you do the derivative, evaluate that then at negative 1. Okay, so plug into your derivative, negative 1, you have 1 plus 2 over negative 1 squared. That's 1 plus 2, that's equal to 3. So therefore, if the derivative of the function at negative 1 is 3, then the derivative of the inverse at 1 is going to be 1/3. Okay, and then graphing on this, I put it in like this, x minus 2 over x, with the condition x less than 0. I did this in a standard window. And again, when I did this and found the derivative at negative 1, the idea is right here, this is f of x. This is the graph of f of x. We never found the inverse. We didn't decide to mess with that. So it turns out that the slope of this tangent line at the point negative 1, 1, that slope of that tangent line on the function is equal to 3, like we got here. Okay, so that means that if there was a way for us to get that inverse, then we would have a 0.1, negative 1 on the inverse, and its slope at the tangent line would be 1/3. So that's the idea. Okay, second one, get a little trig in this. Now this one, there are times when you're doing trig equations where you can solve the equation in your head. You can. If you know your unit circle, you can figure this out. So again, we're not going to find the inverse on this. It's too difficult. So what we're going to do is we're going to look at this value of x. We're going to set the function equal to 0 and solve the equation. Like I say, this is kind of difficult to do algebraically, but you can figure this out in your head, seriously. The tangent of 0 is equal to 0. Okay, on the unit circle, the way this works is at 0, you have the point 1, 0. The tangent of 0 radians is y over x, so it's 0 over 1, so it's 0. And you can just tell that that's right. If x is 0, then, see, it works out. Tangent 0 plus 3 times 0 to the second is 0. So that means we have this point, 0, 0 is on the graph, is on the point on the graph of the inverse. And then if we turn that around, well, just flipping it around, 0, 0 is also on the graph of the function. Okay, and so what I did is did the derivative. The derivative of the tangent is secant squared x. The derivative of 3x squared is 6x. Evaluate at 0. Flipping the point 0, 0 backwards doesn't make any difference. And then when you work that out, the secant of 0, I do 1 over cosine. Remember, the secant's 1 over cosine, and the cosine's 1. So I get 1 over 1 squared, and I get 1. Okay, so what happens is we figured out that the derivative evaluated at 0 is 1. Okay, so what happens is if we do the, now I think I wrote that down wrong there. That means, because we're supposed to find this at 0, not at 1. Okay, so what we'd have is take the reciprocal of 1, you still get 1. Okay, so that's the idea. So what happens on this is a graph right here going from negative 10 to 10, and I think from negative 2 to 2 is how I scaled this. But at the point 0, 0, it's kind of hard to tell on here. It looks like it's got a horizontal tangent line, but it doesn't. That line is sloping one like that. So the slope of the tangent line is 1. So if you take the point backwards on the inverse, you'll have the reciprocal slope, which is still 1. Okay, so that's the idea. Okay, wow, these things can be a little challenging. I think the graph, again, helps students the best. So this is the shortcut that you want to do. Just kind of follow this procedure when you're doing homework and get comfortable with it. The next part of the video that I'm going to do is we'll do the derivative of inverse trig functions. And that's what you're going to be using most of the time in this class and in higher math, particularly in Calc 2. You work with inverse trig functions quite a bit. All right, so that'll wrap up part 3. Good luck. Hope this helps you to grasp this concept. Cheers.